In our last video, we had a look at analytical geometry, the whole overview. These are all the formulas that are usually given to us on the formula sheet, and they will definitely be there at the end of your matric exam. So we saw the distance formula, the midpoints, the gradients, and then the equations of the straight line, two different formats. And then we said there's this new one, m is equal to tan theta, and that is the angle of inclination. First of all, let's just try and make sense of what inclination is, or what the angle of inclination is. So the angle of inclination is the angle formed in an anti-clockwise direction between the x-axis and a line on the Cartesian plane. And there are two formulas that link to gradients. So the one we know very well, y2 minus y1 over x2 minus x1 is gradient. But the other formula here is that tan theta is equal to gradient. And so this boils down to actually a very simple trig equation that we can solve. And so if we needed to know the size of theta, we would then arctan that gradient value. And that's what we're going to focus on today in this video. Now there are two cases that you need to know about. The one is when the line has a positive gradient. In other words, as x increases, so y increases. So it's an uphill slope. And then the other one is where the line has a negative gradient. And that means that as x is increasing, y is decreasing. So a downhill slope. Okay, have a look at these angles here. Angle theta is the angle of inclination in both cases here. And the definition specifically says it's an anti-clockwise direction from the x-axis to the line. So we go from the axis up to the line. There's the angle of inclination if we've got a positive gradient. And if we've got a negative gradient, we'll go from the axis all the way around to the line. And so you'll see a line with a negative gradient has a much bigger angle of inclination. Okay, so when we work this out, what we need to know is that a positive gradient line, we can simply say tan theta equals m, and then we can say that the angle of inclination is actually just equal to the reference angle that we get, because it's going to be an acute. Okay, we get acute reference angles here. But if you look at the second one, you can actually even see that the angle is technically in the second quadrant here. And so that one is going to be a little bit differently, because you're going to say tan theta equals m, which is still the formula. But now to get theta, we're actually going to have to say 180 degrees minus that reference angle. So very important before you dive into solving any of these is to check, is my gradient positive? Because then I can use the angle as it is. Or is my gradient negative? Because then I'm going to need to say 180 degrees minus that arctan of m. And if you can remember that, this section is going to be a breeze. Let's have a look at some examples. So in the diagram below, AB is a straight line. Calculate the gradient of AB and determine the inclination of AB. Okay, so gradient is something we practiced in the previous video. We should be very good at that. Before we do too much, I already like to just have a look at this line and decide, is this a positive slope or a negative slope? Okay, it helps me also to check my answers. So it's an uphill line. X is increasing and y is increasing, so that's a positive gradient. Let's work out the gradient now and see what our answer is. So m is equal to y2 minus y1 over x2 minus x1. And then we simply work that out. So we're going to have 2 minus 3 over 5 minus 4. And what do we get? We get 5 over 9 is the gradient there. 2 plus 3, 5 plus 4. Okay, so that's our gradient in its simplest form. So that's the gradient of AB. And we only have one line there, so it's not really necessary to write that subscript, but it is helpful. Okay, next up they ask us for the inclination of this line. So remember, that's between the x-axis and the line that we've been given. Okay, we've got the equation. The equation says tan theta is equal to m. Okay, so we can then say, well, we know what m is because we've just worked it out, 5/9. And so to get theta, this is a positive gradient. That's true. We did get a positive 5/9 there. So we can simply say theta is equal to arctan of 5/9. And on your calculator, you're going to push shift and then the tan button, and then you're going to put that fraction in. Let us see what the size of theta is. So shift tan 5/9, and I get an answer of 29,05 degrees. Okay, it's an angle, so the unit there is degree. Next example here, in the diagram below, PQ is a straight line. Same questions. Calculate the gradient of PQ, determine the inclination of PQ. All right, before we even do that, have a look at this line. Do you see it's a downhill line? So we want a negative gradient, and I need to be careful to do the 180 minus to get my angle of inclination when it comes to that point. Okay, so first off, calculate the gradient. So gradient of PQ is equal to y2 minus y1 over x2 minus x1. And then I can substitute in. So 2 minus 2 over minus 4 minus 4. What do we end up with? 4 over minus 8, which is equal to minus a half. And that is true. I was most certainly expecting a negative answer there. Now they want the inclination of PQ. Okay, it's got a negative gradient, so I need to be careful now with how I work it out, but that's fine. I'm ready for it. Okay, the formula says tan theta equals m. Theta is formed there between my x-axis and the line. And so what I've got is that tan theta equals minus a half. Okay, so what we know is that theta is equal to 180 degrees minus a reference angle that I need to get. Okay, a reference angle, something to take note of. We'll do a lot more of this when we get into the thick of the trig syllabus, but a reference angle never uses a negative sign. So you basically get an angle. You're going to, on your calculator, you're going to go arctan. Let's write it down. So reference angle is equal to arctan of a half. So you'll see there, I only took the positive a half, which is going to give me a reference angle now. So shift tan 1/2. That gives me a reference angle of 26,565 ... And so when it comes to working out the actual angle of inclination, it's going to be 180 minus 26,565 ... which gives us an answer there of 153,43 degrees. Okay, so because it was a negative gradient, I needed to get a reference angle. In the example before, we didn't have to get a reference angle because we knew that it was already going to be in the first quadrant. Okay, a reference angle is technically what this angle would be if it were in the first quadrant. And then we apply it to where we need it. And we said 180 minus because it was a negative gradient. Let's look at a combination question now. In the diagram below, AC and BD are straight lines. Determine the sizes of alpha, beta, and theta. Okay, so now we've got a lot less guidance to work on, but what we do know is the formula is true. So we can say arctan of alpha will give me the inclination here. Arctan of beta will give me the inclination of that line. And then I'm just going to have to be practical here because this angle here doesn't link to the x-axis, and that's the definition of an angle of inclination. So we're going to have to think about that one. But let's begin, and as we journey, I think you'll see this question is going to unfold beautifully. Okay, so the first thing we're going to do is we're going to say tan of alpha is equal to gradient. So y2 minus y1 over x2 minus x1. Okay, and then let's just color code that line so that we know what we're dealing with there. That's going to help us. Okay, so we're going to substitute in some points. We've got 3 minus 2 over 2 minus 5. So what do we end up with? We've got 5 over 7. Okay, and so now what I want to do is I want to just decide, do I need to take my reference angle as it is, or can I just jump straight into the answer? Okay, well, let's work out a reference angle quickly. Reference angle is equal to arctan of 5 over 7. Remember, we don't worry about signs there. So shift tan 5 over 7. And we end up there with 35,5376 ... Okay, and because this is a positive gradient, then that acute angle is true. So we can say alpha is equal to 35,54 degrees. Okay, so that's alpha. Now let's have a look at beta. Beta is over here, links to this line here. So we're going to say tan of beta, according to the formula, is equal to gradient y2 minus y1 over x2 minus x1. Okay, we're going to take our coordinates 4 minus 3 over minus 1 minus 6. What do we end up with? 7 over minus 7, which is equal to minus 1. Okay, that's a negative gradient, so I'm just mindful of something's going to change when I get to my reference angle. So reference angle is equal to, we're going to say arctan of, not minus 1, but 1. Be careful there. Reference angle ignores the sign for now. So that's 45 degrees as my reference angle. And so because this is a negative line, I'm going to say, well, beta is equal to 180 degrees minus that reference angle, which is going to give us 135 degrees. Okay, so what we've got now is 135 degrees here and 35,54 degrees there. And now I want that third angle, which is the angle theta. Okay, so what you could do, and what most students do, is they work out using angles on a straight line, this missing angle here, and then they use the interior angles of a triangle. But a quicker way to do it is actually to remember a theorem that we learnt already in grade 8, and that is that the exterior angle of a triangle is equal to the sum of the interior opposite angles. So that theorem says to us that beta is equal to theta plus alpha. And the reason there is exterior angle of a triangle. Okay, so then we can substitute in 135 degrees is equal to theta, we don't know yet, plus alpha, 35,54 degrees. And then we can move this 35 across. It's going to become a negative. And so we end up with theta equal to, and we're going to say 135 minus that 35,54, and we get an answer there of 99,46 degrees for theta. Let's look at one last example. Triangle ABC is given below. Determine the size of angle A. Okay, so what I'm going to do is I'm just going to have a look at what's missing and what we want. Let's call this theta. This is the angle that they want. They've given us a 30 degrees here, so some of this question has already been worked out for us. And then the other thing they've given us, and this will probably be in the analytical geometry part of the paper, so my brain is already thinking about things like that. They've given us 2 points, which means we can work out some measure of angle of inclination. Okay, and what would it be? It would be the inclination here of this from the x-axis up to that line. So let's call that alpha. Okay, so what do we know? We know that tan alpha is equal to the gradient, y2 minus y1 over x2 minus x1. So now we're going to substitute in 3 minus minus 3 over 1 minus minus 4. So we end up with 6 over 5 as our gradient there. Okay. Let's get a reference angle. So we're going to say shift tan of 6 over 5. We get an answer there of 50,19 degrees. 50,19 degrees. And then we have just a final check, and we say, well, the gradient here was positive. So that means my angle, alpha, is actually equal to that reference angle, 50,19. Okay, and now it's so tempting to have a look in this big triangle and to panic and feel that we don't have enough information. But we know that there's an angle here, 50,19, and what we need to get good at seeing is that there's actually more than one triangle on this Cartesian plane. Look at that. So we can actually work out in a very similar way to what we did in the previous example, using that exterior angle of a triangle, we can work out the size there of theta. So what do we know? We know that theta plus the 30 degrees is equal to 50,19 degrees, because it's the exterior angle of a triangle. Then we substitute, we move that 30 across, so it becomes minus 30, and we end up with theta equal to 20,19 degrees.